it. Everyone can hear me, correct?
Yep.
All
Yep.
right. So I'm just going to go ahead and start screen sharing here. All right. Can everyone see the screen here so far?
Yes.
Perfect.
Yeah.
So I just realized this should have said November. Let's pretend that didn't happen. But yes, today is going to be the deep dive into Linux. And this is going to be a bit more of an in-depth look into how it operates, some of the, of course, underlying technology behind how it works, and some of the people that make it possible. So let's dive right in here. So to the uninitiated, Linux may just sound like some kind of space age technology. And Linux in of itself isn't a complete operating system. Linux is actually a kernel, which is essentially the core that drives the operating system. So it includes underlying technology that interacts with the CPU. And then you also have certain device drivers for things like, let's say, memory, USB controllers, and even floppy disks, which, believe it or not, Linux does support in some capacity. And it's the operating system that interacts with the kernel in order to drive the device and do things that matter. So, like we had mentioned, because Linux isn't a complete operating system on its own, there are distributions like Gentoo, Debian, and then derivatives like Ubuntu, which you may have heard of, that essentially package the kernel along with programs, a full-featured desktop environment, and sometimes even other drivers and libraries to basically make the experience as complete as it would be if you were using, let's say, Windows or Mac OS. And it's the bundled operating systems that are considered distributions, and most of them are generally going to be free, as in price, but due to the way Linux is licensed, they would also need to be free as in speech, which means that anyone would be able to study, interact with, and modify the source code, and even release those modifications. More on that later. So, the Linux project began in 1991, and the guy who started it just so happens to be named Linus. And he developed it while he was a CS student at the University of Helsinki. So he had developed it as a clone of sorts to the Minix operating system, which in of itself was a clone of the Unix operating system. And we'll discuss that in a little bit. But when he had announced it in a news group in 1991, the summer of 1991, he was 21 at the time. Can you imagine that? He had believed that Linux was just going to be a hobby and it wouldn't be big and professional like the GNU operating system, or GNU, I should say. And this was very, very minimally featured. It was pretty much an alternate implementation of the Minix operating system. And the reason that he had written this project was because at the time, source code was available for it, or for Unix and I suppose Minix as well. But because of the way it was licensed, redistribution of the source code, whether in binary or source code form, was heavily restricted. And it has been said that if there were a competing Unix-like kernel that was readily available at the time, this was the very early 90s, then Mr. Torvalds may not have developed Linux. So, as we had mentioned, Linux was just the kernel at the time. So you separately needed to download what was known as the GNU operating system, or GNU. I should keep referring it as such. These were the supporting libraries and programs that essentially comprised the rest of the operating system. And for the early releases of Linux, they couldn't include the GNU operating system because of licensing differences. They eventually resolved that in 1992 when Linus had decided to publish the Linux kernel under the GNU GPL license. And because of that, that essentially broke down the barriers, and he had worked with the GNU developers to integrate the GNU operating system programs and binaries into future Linux releases to make it a more complete operating system. All right, so next we're going to take a look at what Unix is itself. And of course, there's a bit of history on that itself that we need to delve into here. So Unix was originally developed in the 1970s at Bell Labs. You'll see that name come up a lot in the computer science world because they came up with Plan 9 and some other revolutionary technologies that even are used to this day in a different form. But particularly concerning Unix, this was developed by Dennis Ritchie, Brian Kernighan, Ken Thompson, and some other famous names that you will probably encounter in other CS courses here. But the Unix philosophy was essentially that the OS should provide us as simple tools, each with their own limited functions. So you might have one program that interacts with the screen, and then another that interacts with, let's say, any printers on the connected to your computer. And then there should also be a file system, as well as a system for inter-process communication through piping of messages to essentially allow processes to interact with each other and generally just form the more complete system that you would expect to see. And finally, there should also be a shell and command language that should be available for users to essentially script up more common tasks or even do multiple things at once. And originally, Unix was written in assembly, but it was then rewritten in C to make it more portable, which means that it would be easier to port the Unix operating system to processors or other systems that may not initially have native support for it. And this really enabled Unix and its clones to take off. So the interesting part about AT&T having Unix was that it was involved in a legal monopoly agreement at the time with the U.S. government that it signed back in 1956, where it had said that in exchange for being a monopoly in the telephone and communications industry, they couldn't sell any products that weren't focused on those two things specifically. So because of that, AT&T couldn't actually release Unix as a commercial product, but it could provide the source code for a nominal fee to anyone who asked for it. And that mostly had a lot of success in the educational spectrum, where it just so happened to be that researchers could take the source code and study it. And because of that, there eventually came out this other technology called the Berkeley Software Distribution, otherwise known as BSD, which essentially took the Unix code and modified it in such a way that it became more of a feature-rich operating system where they added features that weren't present in AT&T's implementation of Unix. And eventually, that came to a head when AT&T decided to sue the Berkeley, or the University of California at Berkeley, the BSD authors, for violation of their terms. And then the UCB decided to countersue, alleging that AT&T had secretly taken modifications that UCB had made to the Unix source code and then re-implemented them back upstream without telling them. And that became a very protracted legal battle that apparently was resolved in secret. But essentially, that was part of the reason that there weren't any free, as in freedom, clones of Unix that were available for the hardware that Linus was looking at the time. And that was pretty much why he had created Linux. And back then, he actually hadn't even called it Linux. In its early days of development, I think it was reported that he wanted to call it FreeX or something like that, which was a portmanteau of free and then some other terms, including X, to represent the fact that it's like Unix. But eventually he did switch it over to Linux, despite the implications in his head that I was being egotistical. So here's another fun fact you might find interesting. In the movie Jurassic Park, no spoilers here, but there is a line in the movie where they say, "It's a Unix system. I know this." And the screenshot included here is actually a pretty much accurate depiction of a program developed for IRIX, I think it's called, which also happens to be a Unix-like operating system. And you may see these in Reddit and other forums just expressed as a asterisk and then Nix. And that essentially means Unix-like, so it's not pure Unix, if that makes sense. And then some examples of operating systems that are Unix-like are Apple's Darwin project, which uses the XNU kernel, XNU standing for X is not Unix. And this is an underlying base for pretty much all of Apple's software portfolio. So Darwin and the XNU kernel are both open source, but the components built atop it to form those respective operating systems like macOS, iOS, and watchOS and tvOS are not open source. And there actually is a project, I believe it's called Darwin OS or Darwin 86, that essentially tries to flesh out the open source portion of Darwin to make a full operating system, or to make it more complete, rather. And of course, Linux is a very famous Unix-like operating system. Now, there is a reason why we don't count Windows in here, and that's because it's architected differently. Because even in the days before Windows, back in the days of MS-DOS, The kernel is definitely architected very differently in the sense that not just functionally, like I mentioned here that we have file paths. So if I can actually get the pen to work here, typically you'll see in Windows that file paths will have backslashes in them, but Unix-like operating systems will have forward slashes. And that does seem like a bit of a functional difference as to how the file system is implemented. So we'll also see that on Windows, and potentially DOS as well, you may also see that there are separate drives that are basically represented as drive letters. So you have your C drive, your D drive, and whatnot. But on Linux, you'll see that everything is represented as a file. So you may see that instead of your D drive in Linux, it may be represented as dev and then / SDA, or rather SDB, for example, if it's a physical disk drive. Zero indexing. Forgive the atrocious scribbles here. But essentially, differences like that make it so that the two systems aren't necessarily compatible with each other. And we do mention that modern Windows versions, like Windows 2000, and then pretty much everything after Windows XP, are built atop the Windows NT kernel. And that seems to be a conversation for a completely different day. But just definitely know that the way in which they're implemented can adversely affect simple things like file paths. So I'm just going to go ahead and move on here. And now we're going to talk about the GNU project that keeps popping up so much. So, in the spirit of recursive acronyms, GNU stands for GNU's Not Unix, and then XNU is a reference to that. But the GNU project was launched in 1983 by a man named Richard Stallman with the intent of creating a fully free, and again, free is in speech here, a fully free operating system. So the Free Software Foundation, which was, fun fact, originally developed or created to raise funds for the GNU project, defines free software as users having the freedom to run, copy, distribute, study, change, and improve the software. And that means having full access to the source code. And that is really important for Linux and operating systems based on it, because without without free access to the source code, then it can't be improved on by outside developers, and it wouldn't have made Linux as popular as it is today. So, more on the GNU project here. This was essentially a fully featured operating system for the most part. By the early 90s, they had developed pretty much everything needed to complete the operating system, except for the GNU herd kernel. Apparently, that didn't attract a lot of development, and it just so happened that around the same time here, we have the Linux kernel being developed. And in the early release notes, Linus Torvalds does mention that the kernel by itself is not going to be operational without supporting libraries to make it a complete operating system. So the GNU operating system in particular here. So when the Linux kernel was relicensed in 1992, the developers did work together with Linus, I forget how it's said. They worked together to essentially integrate the the two projects into what's known as GNU or GNU/Linux or GNU plus Linux when combined. And there is a difference between what one might call Linux and what the Free Software Foundation explicitly defines as GNU/Linux. So GNU plus Linux is a variant of Linux, and there are distributions that strive to be explicitly GNU plus Linux friendly, but not all Linux distributions are GNU compatible. So we'll see this, for example, with Ubuntu, where during the setup process, you may be asked to download certain libraries in order to enable MP3 playback. Because the MP3 codecs are proprietary and they need to be separately downloaded, and they can't be included directly in the source of the kernel as you download it, then that's considered a not friendly to freedom by the FSF. And so they will strongly recommend that you use GNU plus Linux friendly distributions in order to attain true freedom or the ability to run, copy, and improve the software as they define here. And then this is actually their mascot, which is the GNU head. This is the original version. I believe they have a updated version on their website. And then I think I may not have pointed this out yet, but this logo here is Tux, the Linux penguin. There's actually a fun story about that if you do some research here. Apparently Linus was bit by a penguin. And so based on the description, they drew this, and now he's been the official mascot ever since. So as we mentioned, the Linux kernel is open source and people are able to contribute to it. Some tidbit here. Git was actually created by Linus for the Linux project because prior to 2002, so that would have been a time period of roughly 11 years, we would see that changes to the Linux kernel would be passed to developers by way of file archives and patches. And that seemed to work for a while in the early stages of Linux development. But definitely as time grew on, the Linux kernel became more complicated and larger, and making patches would be a lot harder, especially if a lot of information has changed. So in 2002, they switched to a proprietary VCS or version control system called BitKeeper. And about 3 years later, in 2005, relations between BitKeeper and the Linux development project grew really tense. And so unexpectedly, I would have to do more research on that, but the BitKeeper team had actually revoked Linux's license to use the software free of charge. And so because of that, the Linux development community, and Linus in particular, was compelled to develop an in-house tool for open collaboration on the kernel based on what they had learned using BitKeeper. And so Linus had written up Git as an open source replacement, and now it's in use, widespread, millions of projects, and of course there's GitHub, which definitely hosts Git repositories. And then there's actually a little bit of information as to how the Linux project is managed nowadays. So back in the early days, of course, Linus definitely wrote code, and nowadays he has a say in Linux releases, particularly in in which when stable releases are called just as a merge window, but he definitely isn't the only developer on the project. And more on that later here. But the source code is organized in several different folders, and then those folders are abstracted into several different subfolders to essentially separate the kernel-specific code from device drivers. And then you also have some files in there for documentation, including how to contribute to the Linux project itself, which is very handy. But those subfolders can correspond to different subsystems or even individual drivers for the system. And because the Linux project is so large, each of these subsystems and even drivers can be managed by different maintainers. And these maintainers are typically individuals, and they can either contribute on their own personal time, or a company can sponsor them to contribute to the source code and help maintain that area of Linux. And they often are paid. I think there was a figure on the Linux Foundation's website that had said that roughly 80% or so of Linux kernel developers are paid. So as we mentioned here, Greg Hartman, I'm not going to even say his name here. He's the lead maintainer of Linux. He's essentially Linus Torvalds number 2, and he has served as leader in the past. So back in the early days of Linux, when they didn't have this organized structure for maintaining the source code, it is very much possible, or was very much possible, that if Linus had gotten hit by a bus, the future of Linux could be at stake. But now that they have this system in place, Linux would completely chug along without a hitch, even if Torvalds decided to retire or if he tragically is no longer able to contribute. So as we had mentioned, Linus manages the merge windows for future stable versions of Linux, and he goes through Greg and the other maintainers, main maintainers, I should say, who will submit patches upstream to him when a merge window is nearby for the next stable version of the Linux kernel. And he trusts that the maintainers will not send him bad patches. So once a merge window is closed, he will review them, the patches that have made his way to his desk, and he essentially gives the go ahead and thumbs up for future releases. Now that being said, he doesn't necessarily maintain releases after they've been released. Greg does manage stable releases after the fact. Like, let's say a patch needs to be made to fix a security issue, then changes can be worked on with Greg and maintainers of those particular areas affected. And like we had mentioned, Linus has taken time off in the past. So some context on this, he has been historically hostile to developers who have submitted patches, and he would cuss at them in mailing lists. He was quite verbal about that. And there were points at which he literally gave NVIDIA the middle finger in response to some contributions they had made that were making it very hard for the Linux community to work with them. And in 2018, it came to a point at which he had taken some time off to do an introspective reflection on his behavior and how he could work on that to be less hostile. And that had resulted in the modification of the code of conduct they had adopted what's known as the Contributor Covenant, and that essentially is a document that states how developers should be treated and, in essence, must treat each other when interacting both in and out of the source trees. And there have been mixed reactions to the Contributor Covenant, but it overall seems like a positive. And since the time away, it seems very much clear that Linus is more level-headed and seems to take a more rational approach to explaining why he might not approve a particular kernel patch, let's say. So let's go on here. And yep. So because of the way Linux is licensed under the GNU GPL, or General Public License, specifically the GPL version 2, all kernel source modifications must be made publicly accessible as part of the source code if binaries produced from that source code are distributed in a public manner. So that certainly applies to Linux and any projects that utilize it, like parts of Android here, particularly the kernel. So because of that, manufacturers must release kernel source code in a timely manner. But there have been instances where they would do so months after that, if at all. Some notable examples here: Xiaomi and Motorola. And the GNU GPL has also been ruled in the U.S. courts, I think it was past couple of years, to be an enforceable contract in the U.S. So that definitely provides some legal basis for challenging violations thereof. And the Free Software Foundation is very happy to back you if you find out that you're affiliated with a GPL project and your rights are being violated. And I believe there actually was a court case, either several thousands or several $1 million worth, of companies that did use GPL code, but then didn't acknowledge it or would explicitly hide that fact and then would not publish their sources. And that can be truly catastrophic. So the takeaway here is make sure you're following your licenses. So we'll move on here. And we're going to talk about some real world examples of Linux. Like we had mentioned here, Android definitely uses the Linux kernel, as does Chrome OS. You'll also see Linux being used in Wi-Fi routers. So there's a fun fact there. And then there are also third-party solutions like, I want to say, DDWRT and OpenWRT that essentially allow you to modify your router firmware in order to get additional features that you wouldn't otherwise have with the stock firmware. So we also see that some cars, not just the infotainment systems, but the code that powers the cars themselves, can also be Linux-based. And we can also see that some TVs, like the Roku TV, and then auxiliary devices that you'd plug in, like Roku, Chromecast, and even the Fire TV series, those are all in one way or another based on the Linux kernel. And in the case of Chromecast and Fire TV, I believe they may also be based on Android. So some fun tidbits there. Besides that, there are also other applications for Linux. Like, you'll definitely see that it powers Raspberry Pi. So it's a very inexpensive credit card sized computer. And of course, they're coming out with more powerful models as time goes on. So that's always great to see. You'll see that it can power website servers. So both in the commercial space and the government. I want to say that even the Library of Congress runs on Linux servers. You can see it on other servers, even here at UW-EC, like the Phoenix servers, formerly known as the Thing servers, run on a distribution of Linux, though the particular distribution eludes me. And then you'll also see that a lot of supercomputers. Oh, it looks like maybe chat here. I totally didn't notice the chat. Ah, yes, CentOS. Thank you for that, Cole. Fun facts. You may actually be able to do a command in the things or Phoenix servers to essentially pull for what kind of Linux variant is running, and that definitely is CentOS based with the Phoenix servers. Anyways, you'll see a lot of supercomputers run Linux-based operating systems because it definitely has scalability. It's fast, and most of the time it's optimized for low-power devices too. So you'll even see them run some lower-powered hardware, just simply because the overhead that's saved compared to other solutions. So CERN is one of those supercomputers, for example. And it's even been deployed by NASA. So I know at least some of the computers aboard the International Space Station use Linux. And then they've also deployed rovers, like the Spirit rover on Mars that ran from 2004 until it got lost in 2011. That also ran Linux. So this all proves that Linux is really versatile as far as where you can port it, what it can do, and pretty much the sky's the limit. So we'll move on here. And yeah, to demonstrate how powerful free software is, I actually took the liberty of spinning up a Pop! OS distro, which is based on Linux, or Ubuntu, which is Linux based. I already had the distro installed, but I decided to compose this entire presentation entirely within LibreOffice Impress, which acts in a similar manner to the Microsoft Office suite, but does have some distinct differences, as you can tell in the screenshot here. And then the text enclosed here is known as the GNU plus Linux copy pasta, which is essentially riffing on the fact that without the GNU software that comprises the GNU operating system, you don't really have a full operating system with Linux. So some of this is factually correct, but as explicitly stated by the Free Software Foundation, this isn't entirely factually accurate. I just threw it in there for some laughs. And I did want to include a couple more sides that I didn't get to here in the presentation. You do have avenues for spinning up Linux to test it out yourself. So obviously one way to encounter Linux is through dual booting your Windows partition. So if you should happen to have the propensity to, you can definitely go ahead and spin up what's known as a live CD. And that could contain whatever distro you decide to install, like Linux, Ubuntu specifically, or any distro thereof. Sometimes even other distributions like Chrome OS or There are some other names. The list could go on for miles. But essentially, you can either try them out while you're booting off of a USB stick or CD. And if you decide you want to keep it, you can install it to your hard drive to either replace or work alongside whatever other operating system you may already have installed. So you'll probably hear the term dual booting a lot, which is effectively just going to say that you have Windows installed on one partition, and then on another, you might have Linux here, and you can choose which to boot when you start up the computer. Some of you may have heard of it and tried it. Some of you may not have, but definitely it's one way to get your hands on Linux. Another way is through what's known as virtualization. So there are programs available like VirtualBox and VMware, where essentially you run your host OS, so let's say Windows here, and then inside Windows, you start up a container known as a virtual machine, where you can then install, let's say, Linux, let's say Ubuntu, right? And if it should happen that something happens in your Ubuntu installation here inside the virtual machine, generally speaking, your Windows installation is safe. So you could then go ahead and delete the virtual machine and all your files are generally still safe. And that's definitely another approach. Another approach yet, actually, is within newer versions of Windows 10, there's actually this thing called WSL, which stands for the Windows Subsystem for Linux. And what that does is it enables you to run a Linux distribution like Ubuntu or CentOS if you should so choose, inside a container, but it runs inline Windows. So you would have Windows running, of course, but then you would also have a full featured Linux shell for if you want to, let's say, run GCC. And it's different from virtualization in the sense that it's still running inside Windows, if that makes sense. The specifics of it differ, and they actually have two flavors of WSL. One of which requires Hyper-V to be enabled, which is a virtualization tool. We could definitely have another presentation about that. But yeah, those are definitely options you have to get your hands on the Linux shell. So I'm just going to say that the template that was used for the presentation here was licensed under the Creative Commons 3.0 attribution share alike license, and it makes use of the works of Matheus Luna.